Welcome back to Muddy Math, where we take middle school math concepts that are a little muddy and clear them up. Today is a supplement video to Day 16 wrap for the 28 Days to Phi journey. In the Day 16 video, I demonstrated the process of creating a very precise net for a scale model of the Pyramid of Giza. Now, I hope you took some time to try to make one on your own. Okay, this is mine with precision. I used straight edges and proportions, just like I showed on the Day 16 video. So what I want to use the supplemental video time for is showing you how we can relate 2 dimensions to 3 dimensions, thinking about surface area and volume of the Pyramid of Giza, and then also touch base on that right triangle relating the square root of phi to phi, and showing how that creates a cross section in the Pyramid of Giza. So here's the net of my model of the Pyramid of Giza, and wow, it's a perfect little model. These isosceles triangles have a height of phi. The height of the pyramid, however, is the square root of phi, which is really cool. And how can we visualize that? Okay, so that's a peek inside of the pyramid, and what you notice is the height of the pyramid is not phi, because phi is this vertical height, and you can see, let me just get it situated here, that a height is measured when it's perpendicular to its base. So you see that this untaped face is sticking straight up from the square base. Okay, straight up from there, that length, that is phi. You can see that the apex of the pyramid is less than that, because we take these faces and we reach them into each other, that height decreases, and it actually is now specifically the height of the square root of phi. That's why this ratio is so intriguing. Connect 3 faces of the model of the Pyramid of Giza, and now we can use right triangles, the special right triangle 1 square root of phi, and put them inside here to help you see the cross section straight through the apex perpendicular to the square base, and see the actual relationship of the right triangle there, and see that the height of the actual pyramid is the square root of phi, where the slant height is phi. So I used the 2 corners of paper to form right triangles because most paper already has a right angle in the corner. Now I have 2 special right triangles relating 1 in the square root of phi to phi. 1 and the square root of phi are the legs of the right triangle, and the hypotenuse is phi. If I tape these together, I'll form an isosceles triangle that has a base of 2 and a height of square root of phi. This isosceles triangle is a cross-section of the Pyramid of Giza. This is a cross-section of the Pyramid of Giza perpendicular to the base through the apex. So what I'm going to do is line up the base of the cross-section with the center of the base. Since the center of the base is right below the apex, since they're connected with a perpendicular line, I can tape my isosceles triangle, my cross-section, to the bottom of my pyramid at the center, and then that way when I lift it up, I can see the cross-section. So this shows you all the right triangles that are in play here with the construction of the Pyramid of Giza in Egypt, as well as your scale model. I hope you enjoyed taking something from 2 dimensions, our net, folding it up into 3 dimensions to see the solid form, but then again returning from the solid form to a 2-dimensional analysis by looking at the cross-section, the slice of the Pyramid of Giza through the apex perpendicular to the base. Now make your scale models of the Pyramid of Giza. Give it a try. I hope this video answered any questions you may have had after the Day 16 live stream of wrap for our 28-day journey to Phi. Take some time to try to construct your own scale model of the Great Pyramid of Giza. Fold it up, put it in your pocket, and see if any nature objects fit perfectly inside. See you tomorrow for day 17.